Good evening, everybody. We have an exciting lecture for you tonight. You know, this is about the power of coordinated science. 125 years ago, there was a person with the wisdom and vision to put together what it was the first International Polar Year. That was 1882. And there's been an International Polar Year 50 years after that, in 1932, during the Depression. So there wasn't much funding for the work there, but again, the power of coordinated science brought great results and added momentum to our understanding of the polar regions. And then a different vision pervaded that brought about what was called the International Geophysical Year in 1957. And in that particular time, the vision was not just the polar regions, but the entire globe. And the International Geophysical Year came about with the idea of developing the science of geophysics to a high degree. And that's when actually Fairbanks came into the situation much more prominently than it had been in past efforts. There was a man named Sidney Chapman who came to Fairbanks as a scientist and a leader who became one of the global leaders of the International Geophysical Year. We were proud to have him as Associate Director of the Geophysical Institute at the time. And you might know that there is a Chapman building in the university and now a Chapman Chair commemorating Sidney Chapman and his work in IGY. Well, now we are 50 years further on, and this is the fourth, if you like, in the International Polar Year series. And we're going to hear about the exciting things that are being planned. And I might add as a rider to this that in this particular year, which is just starting, there are actually 3 other international years that are acting at the same time. There's the International Heliophysical Year, the International Year of Planet Earth, and what's called the Electronic Geophysical Year. All these things happening together, and actually they kind of represent what was done in the IGY. But tonight, our focus is the International Polar Year. And we have as our speaker, Hajo Eicken. Hajo is one of the faculty at the Geophysical Institute. And some years ago, he came here from one of the most highly acclaimed polar institutes in Europe, called the Alfred Wegener Institute, where he was a group leader. And he's coming to talk to us tonight about the International Polar Year. And the International Polar Year is the university's main focus of research. And I believe tonight we are fortunate to have Steve Jones and his wife Judy, Chancellor and Chancellor's wife. Steve, are you here? And so, without delay, introduce to you Hajo Eicken.
Thank you, Roger, for those kind words. Now, Roger was, we were standing back there, and Roger was saying, well, with these titles for these talks, you got to work on that. And, of course, the problem with big, coordinated international science is that if you try to find a pithy title for a talk, it's something like, 125 years of boredom, or committees, or the excitement of planning and revising plans and things like that. So I'm actually glad that Roger gave a brief introduction of what this is about, because that allows me to immediately go to the conclusions of the talk tonight. And the conclusion basically is that it's about more than a whole bunch of scientists or planners sitting together and saying, well, we got to do something, every 25 years, every 50 years, or whatever, we ought to have a big event that really allows us to feel good about ourselves. We can go out and recruit new young researchers. And I'm glad that, I see some young researchers out there. And I do hope that you're getting extra credit for this, too, as hopefully I will. I'm glad the Chancellor's here. I'd probably negotiate an extra holiday, right, or something. But the interesting thing is that I guess I don't want to come across as too jaded, but if you would have asked me about 3 or 4 years ago, about the International Polar Year, I probably would have said, well, that's sort of like detention. It's just that it takes 2 years, right? You're sitting in there in this committee for 2 years, and it's not all that exciting because, as Roger aptly pointed out, a lot of these big initiatives require a lot of planning. And what's kind of nice now is we're not at the point where, you know, the planning phase is over. Whatever isn't really well organized is still going to go forward, and the excitement is about to start. And the question, of course, is, well, what is all this excitement? And what I'm going to try to do tonight is basically provide you a bit of an overview of the history of these polar years. Also because I do think that, you know, if you look up at the screen here, we find that Alaska really was a key component of the first International Polar Year. I'll tell you a bit more about the building that you see up here on top of the screen. But we also find that we're in a great position for a lot of the things that are happening right now in the Arctic regions, which are more than just about research and science. And so I think the take-home message today is that if we look at the history of these International Polar Years, I don't think there's ever been one where so many things have come together just at the right time and in a way that allows pretty much everyone, at least people who have a computer or some means to call somebody else who has one or who can come up to the university to get involved. And that's ultimately what this is tonight, is mostly an invitation for you or for people you know in town and elsewhere to get involved. So having said that, maybe I should start out by saying, well, what exactly is the International Polar Year, IPY? And maybe I should start off by saying, I mean, who here, before you saw the announcement of this talk, has never heard or had never heard of the International Polar Year? All right, good. I like that. And you're probably here for extra credit too, right? All right, so am I, so we're in this together. So what is the International Polar Year? Well, if you ever try to find out, as you probably know very well, and you have no clue what do, you Google the thing. And if you Google the International Polar Year, well, what do you get to? You get to this website here, currently at number 1 of the list, www.ipy.org. And you consult that website, and they tell you, well, it's a large scientific program, focuses on the Arctic and the Antarctic. It's going to happen or take place between March 2007 and March 2009. It's an unprecedented opportunity, and it also allows people in ways which we haven't been able before to get involved with a lot of cutting-edge science in near real time. And I'll show you in a little while what near real time really means these days. And then the website also talks about the urgencies of IPY. And they actually specifically reference the changes in the snow and ice cover, talk about global linkages, about the fact that we have a lot of different neighbors in the circum-Arctic, and they talk, of course, about scientific discovery. And later on, I'll try to really look into those different things in a bit more detail, because I actually think that in many ways the IPY website as a whole isn't even getting to the really interesting stuff quite just yet with these fairly generic statements. And then, of course, with regards to the history, as I mentioned before, there have been IPYs, or the International Geophysical Years, in the past, starting in 1882-83 with the first one. And the last such initiative actually was the big IGY, which probably at least some of you are familiar with, International Geophysical Year, that involved, at least for the times, a lot of researchers, a lot of people from a whole bunch of different countries. And in fact, I was just reading up about this the other day. Back in 1957, the budget of the National Science Foundation was about $8 million. It was a very fledgling institution, just starting to grow. The budget for the International Geophysical Year in the U.S. amounted to $47.5 million. Now, in real, in today's terms, that's way, way more than even the most enthusiastic scientists like myself could expect to spend over the next 2 years. So it does tell you something, that there is a very, very strong and long history of this type of research. Now, if we look at the, so you delve down a bit further into the website, and you might ask yourself, well, how involved are people from Alaska, or what does this really mean for us here? So I did a very, bare bones search of the various projects on the database, and you can see this. I hope everyone at the back there can read the titles here. And in fact, is there anybody at the back who's taking this course for credit as part of the continuing education? I don't see any hands, but you're going to be quizzed on this here, so you better make sure you know what these little hexagons are all about. But the bottom line really is what it has up there, and that is that roughly 1 in 5 of the Arctic projects, which account for the majority of projects actually that are part of the IPY, involve Alaska directly, either as a research location or as a direct university partner. And then about 1 in 4 actually have University of Alaska participation, and something that I actually found quite striking because I didn't expect this. I was going into that website and I learned a lot about what my colleagues are doing at the university, and I found that, in fact, 16 out of these total of 228 projects are being led by researchers or educators at the university. And basically that says, because these are endorsed projects, that are evaluated by an international committee, that really does tell us that we're doing something right. Now, if you look at this, well, now this one you should definitely be able to read at the back. But if you go through this, it's a really interesting diagram. I still haven't figured it quite out, but it does tell you something about how many projects are active in the Arctic, or both in the Arctic and in the Antarctic. But if you just take some examples of projects involving people here at UAF or at the University of Alaska, my colleague Sarah Fowle in the Department of Geology, she has a project on Bering Strait, and in particular the look at the land bridge, which of course plays an important role also in the settling of Alaska and the North American continent. There's a project by Gary Kafinas at UAF who's looking at, now who here knows what a rangifer is? Well, who doesn't, and that includes me, but I looked it up. It's sort of science speak for reindeer or caribou, and it already tells you something, and I have to admit that too, that you read these titles and you have no clue what this is about. But this project here, as I understand it from talking to Gary, really does tell us more about what's happening to caribou and reindeer, both from a husbandry perspective as well as from a wildlife perspective. And it's something that involves a lot of native residents of the Arctic as well. There's another project that specifically looks at the living conditions in the Arctic by Jack Cruz from the University of Alaska in Anchorage. Elena Sparrow here at UAF is actually heading the Education Outreach Office of the University of the Arctic, so that's quite interesting. There's actually a census of marine life going on that's coordinated by Rolf Gradinger here at the School of Fisheries and Ocean Sciences. They're still having problems trying to get the ringed seals to fill out the forms, but as with the real census, there's all these interviewers that you can send out there, and they'll take down your responses for you. And then finally, there's a project that I find quite interesting by Skip Walker at UAF that looks at the greening of the Arctic. And that sort of brings me to what I want to talk about a bit more now is, well, what's actually going on in the Arctic? Why is it so interesting, even for people down in the lower 48 or, say, Mexico or other countries, to actually care about what's happening up here? Well, the first question, of course, to ask is, if we think about the Arctic, let's look a bit more at the history of the International Polar Year and then go from there. Roger already mentioned this. There's a long history, but if you look at big coordinated international programs, they always start with something that is required to really make progress, and that is a disgruntled field researcher. This is a nice painting of a disgruntled field researcher. Supposedly this is the guy who actually founded the first International Polar Year. He spent something like 3-4 years out with the Austrian-Hungarian North Pole expedition. They really didn't get very far towards the pole, and they also had a lot of disagreements about what to do while not getting to the pole. And so he came back and he said, dang, well, the first thing he did was actually write a really nice textbook about sea ice, which I on occasion still consult. But the other thing that he did was that he said, things have got to change. I mean, we're we're now at the height of the imperial age, but somehow we're still not able to get a group of 20, 30, 40, 50 people out there and actually make a decent set of measurements. So his conclusions from this whole effort was that, you know, even though we had all these people out there, what they did really wasn't ultimately of scientific value. And I think that's a very, very important step in recognizing that even a lot of the exploration that took place afterwards, you know, Peary's push for the North Pole and other things were very, very interesting, had a grip on people, but they didn't really necessarily contribute much to science. And this guy here, Viprek, recognized that, but he didn't just recognize it, he also was able to convince a large number of other scientists in different nations to say, okay, what are we going to do about this? And the interesting thing is that they started something that really was almost like a theme that ran through all of the following polar years, and maybe even this one, I don't know. And that was that if you want to be successful at this, well, first of all, you got to have money, right? You need support. And if you want to convince people who can support you, you have to convince them with something that's of actual use. And so the big push of the first international polar year in 1882-83 was to say, well, we want to make observations of the environment that are useful. A lot of that related to geomagnetism, related to navigation, Earth's magnetic field, but also weather and climate. Some of it was fundamental and applied research, relevant for navigation, geography, but it was also very much, and if you look at these numbers here, these are the different sites that were occupied by the countries that participated in the first IPY. It was a lot about, you know, staking a claim. What was interesting, though, was that the U.S. contribution really was, in many ways, quite different from that, even though it was basically, if you read the original reports, it's almost like it was the tension for somebody at the U.S. Signal Corps to be sent up to Barrow and lead this expedition. You know, his personal account is a bit depressing at times because you felt, well, he was sort of sent up there and he didn't really know what this was all good for. But in fact, the small group of researchers established a hut, observation hut in Barrow. And the amazing thing is that if you go up there now, there's in all likelihood parts of it still standing. That's one of the very, very few buildings from that first IPY where you actually have still parts of the structure in place. And the other interesting thing is that these people made a bunch of really interesting photographs of the general area that we can compare with conditions today. So the picture that you see here is one that was taken near where the hut is of the beach in Barrow. You see a whaling boat here, top of a dory on the beach, and you can see grounded ice in the background. That's something that we can directly compare to today's condition, and that's what makes these former observations so interesting, is that we can go back and compare, and that's what's shown in this plot here, is basically the run of the seasons, 1st of January, end of May, September here, and then into December. We can compare when freeze-up and breakup occurred during those early years. So the first IPYs here, they kept very good records of this. So you can see breakup happened, you know, around about May 30th or so. Not very different from when it happens today, actually. And you also see that freeze-up here occurred sometime at Barrow, sometime in late September. And you can see that the more recent observations from 1970 through 2000, when we have, you know, those records that people are collecting now, that yes, there is a tendency for somewhat later or possibly earlier breakup and freeze-up, but we'll look at that in a bit more detail in the second half of the talk. The other interesting thing that people did during those years was, and it's almost, again, sort of, you know, it's almost like an afterthought. They thought, well, okay, if we go up there, we have the local residents, the Inupiat population of Barrow, somehow, you know, maybe we should take along an ethnographer, somebody who goes along and sort of documents how people live up there, because there really hadn't been, up to that point, a lot of contact. And it turns out that this guy, John Murdoch, really produced one of the most valuable outcomes of this whole expedition. There was a lot of serendipity there, but the book that he published about this is a classic. It's available as a reprint. Very, very interesting reading. in part also because when he was up there, he realized that whereas these folks from the Signal Corps were all making all these measurements during 2 years, effectively, if he talked to local people, he could actually find out what conditions would have been like over the past 50 years or so. And they told him in great detail about how the climate had been more severe in the middle of the century. They told him a lot about whether that year that these guys were making measurements up there was typical, which apparently it was. And so he learned a great deal by directly working with the local experts, who, of course, knew way, way more about anything that these other folks recorded with respect to the local environment than the scientists who came up there. And that's a sort of a continuing theme that often you get people, including myself, as a scientist, you sort of tend to think that, well, I know everything about my field, so you go up someplace and you run to a local and you tell them gladly about, everything you know, and if you do that in a place like Barrow, people entertain you for a little while, and then once you've listened to them for several years, you find out that, well, they really know way, way more, and it might be better for you to start asking people what they know rather than vice versa. But it turned out that this partnership, in particular in Barrow, which I think is really remarkable and something that we should we should cherish and treasure, that partnership between local residents who have this really deep knowledge of the environment with scientists was something that was started in 1882 or even earlier, arguably, and has carried through this present day. And I think that's one of the reasons why Barrow now figures so prominently as a key research site in the Arctic anywhere. Okay, so let's move on to the IGY. That's actually the third international polar year. The second one in the early 30s was a sort of a low budget type of approach, even though it did have some interesting ramifications for the university here, but I don't want to spend too much time on that, because really what was interesting was in 57, 58, things had drastically changed. If you look at this, it's obvious graphic design had made jumps ahead. If you compare this figure here, you can see that both photography and these two young students are just looking in wonder at this fantastic rendering of the globe that's possible with the aid of crayon and mass printing. Less flippant, of course, is the fact that, yes, I mean, technology had made vast progress, and in that way, the International Geophysical Year, which I would still consider somewhat parochially as an international polar year, was a very, very interesting enterprise. Why was it interesting? Well, on the one hand, the arguments that were made about why we need this big, big push to explore the poles, and during those years, it was mostly going down to Antarctica, studying the ice sheet, looking at the aurora. Roger already mentioned that. Sidney Chapman, who was closely affiliated with this university, was a key driving figure. Shun Akasofu started his career here at the university at the end of the IGY, looking at the aurora. So there was a lot of this type of study, but all of this was underpinned by just a single or just two words, and those are, of course, Cold War. If you look at the documents, and in fact, again, if you're really bored, I would advise you to Google Eisenhower presidential documents, and you can actually look at Eisenhower's records from that time that describe in very nice and great detail how he was involved in the planning of the International Geophysical Year. And the interesting thing, of course, is that back in those days, you had several challenges to deal with. For example, that a lot of the data that people were collecting were actually classified. And the Navy in particular was very adamant about saying, well, if you make a weather observation, this could be relevant to national security, and so we don't want this to get out. So the scientists, on the one hand, had to convince people that international collaboration is actually to everybody's benefit, and I think it really speaks a lot to both that age as well as to the power of science to transform and really transcend the political, the political banter of the day, that they were able to say, look, I mean, science is all about exchange. If we classify this information, we will not get the other countries to contribute in equal fashion. And Eisenhower himself, actually, and that's the statement here at the bottom, recognized this, and he said, look, I mean, we're going to collect data, other people are going to collect data, we're going to benefit from it, others are going to benefit from it. And so there was a lot of activity, in particular out of Alaska. Again, Barrow was a central staging point for a lot of expeditions that maybe some of you may be more familiar with than I am, where people were dropped off at scientific camps on the ice. There were a lot of overflights. Of course, satellites were a big topic, and there was a push to get satellites into orbit during those years. But one of the most amazing, at least from my perspective, even as a scientist, one of the most amazing outcomes of the IGY was the fact that at the height of the Cold War, or well, let's say at the start of the Cold War, when it was entering its hot phase, if you will, you had Russia and the U.S. On opposite sides, and they were able to put aside the differences and say, okay, here's this big continent, Antarctica. We're going to develop this continent for peaceful purposes. We will not lay any claim to this continent. A whole bunch of other countries did, with very little consequences to this day in many respects. And I actually regard this, or I would put this to you, that this tells us a lot about what we could achieve during this fourth International Polar Year if we think about the spirit of international collaboration that recognizes, and I think that was ultimately the recognition here too, is that the world is finite. In those days, it was Antarctica that was the last big white spot on the map, and people said, hey, this is more important. This really goes beyond all of these daily, sometimes very difficult conflicts at the geopolitical level, but we recognize that this is something more that goes beyond the day-to-day activities here. So I'd like to now examine in a bit more detail what this might mean in the way of opportunities for Alaska. And I mentioned earlier, I said, well, so what's so special about the fourth International Polar Year? You could say, well, I mean, if you read the newspaper, you read about things like, well, the polar bear is now under discussion to receive threatened status as a species here in the U.S. There's a lot of discussion about the receding ice cover. Of course, here in Fairbanks, we're familiar with discussions of melting permafrost. So it's clear that there's a lot of change in the environment. It's also clear that there's a lot of change if you look at the northern populations. If you go to Canada in particular, it's very interesting to just follow the political development there with the independence of Nunavut, which grew out of part of the Northwest Territories. And the same thing is happening in a lot of other circumarctic countries as well. The third point is that we see a big change in the geopolitics, the way different countries interact in the Arctic after the formal end of the Cold War, which arguably was sometime in the late 80s or early 90s. And I'll show you a bit more about what that actually means. And then finally, we also see more of the linkage between what happens here to what's happening at lower latitudes. Part of that, you could argue, is due to the internet, but there's also other things that are driving this. And I want to pose a question here, and that is the question whether, if we look at all these changes that are currently underway, whether we're in a good position to really take advantage of those opportunities that these changes offer us, while at the same time also dealing in a responsible fashion, in a prudent fashion with the consequences or the challenges. And that's something where you would say, well, I would argue, even as somebody whose sourdough status is abysmal, I hate to say, as you probably already gathered from Roger's presentation there, I would still argue that this is where Alaska can make a substantial contribution. So let's just briefly go through these 4 different points I've put up here. And I just want to show you, sort of highlight some examples of where I think, we have things that are important to keep track of, but also things where we can contribute. The first one, of course, is, I already mentioned, is change in the Arctic. And my personal area of expertise is the study of ice on the oceans. And I have to admit, I do a lot of field work. I'm not a modeler. But I have to admit that, if you would have asked me 5 years ago about, well, where do you think the Arctic ice cover is headed, I would still have been fairly cautious and would have said, well, I know something about ice albedo feedback. 2 slides from now, you will too, I can assure you. But I would argue that, you know, this is going to take some time for that whole system to respond. Now, if you ask me this year, I'm already, I guess I'm not, personal job security, I think I can barely scrape by as a sea ice researcher, but I do make sure that my students, or students working with me, are aware that this is not necessarily, if you want to study the perennial, you know, the year-round ice cover of the Arctic, it's not something you want to hang your hat on for the next 50 years or so. And so what you see here on these plots, in fact, are the ice conditions during the summers of 2002, 2004, 2003, 2005 here. And you'll notice that Alaska is here, so Fairbanks is here somewhere. This is where Barrow is, my little arrow there pointing this out, or trying to point this out. And you'll notice that in particular in the western Arctic, here north of Alaska, have we seen the biggest changes in the ice cover compared to normal conditions, which are represented by this line. So if you talk to people in Barrow, it used to be that if they would go up to the beach on a regular day in July or August, there'd always be ice around. Very important for them, of course, from the perspective of going out hunting, a lot of marine mammals and other animals associated with the ice. These days, you go out there in a lot of July's, August, or September, and the ice edge is 150 miles or so away, which means that the storms that come into town from the north, which seem to have gotten stronger, can build up more waves. There's problems with coastal erosions and a whole bunch of other issues. But at the same time, of course, you know, people say with oil companies who might be interested in exploring for oil and gas resources on, say, the Chukchi Shelf here, and I'll show you more about that, or looking at this and saying, well, does this mean this is now an open Arctic Ocean in the summertime? And of course, that's one of the interesting questions here. What is interesting also is that if we look at the climate models, and what you see here on the left is a curve that shows one climate model prediction for the maximum extent of summer sea ice in millions of square kilometers in the Arctic, going from the early 20th century all the way to the end of the 21st. And you'll notice that these models consistently actually show a dip in the ice extent in summer that starts somewhere around about where we are now. So one conclusion is that clearly we're living in interesting times. Another conclusion is, and I'll show you a bit more on that, is that these models still are, in general, giving us a good assessment of the trend, but it's very difficult to pin them down on specific years or specific regions. I mentioned ice albedo feedback, and I do want to point out that one of the important things here is that we may have started something that is going to be very, very difficult to actually bring back, and that is a result of what's known as ice albedo feedback, which basically tells us that if we look at the highly reflected snow and ice of the northern hemisphere or the southern hemisphere here, we actually find that most of that, of this reflection comes from snow on sea ice in the Arctic. Here's Greenland. Again, Barrow is up here. And if we compare, you can just see that from the picture here, if we compare the dark ocean, which tends to absorb more than 90% or 9/10 of the heat that comes from the sun, if we compare that with the ice, which reflects at least 3/4 of that, it's easy to see that if we change the amount of snow and ice, we're going to change something about the way the Earth stores and receives heat. And that is a very, very important aspect here, is that I think in Alaska in particular, if we look at the oceans north of Alaska over the next few years, we're gonna have to watch this very closely to see whether this is part of a continuing trend or something that is different from what most of us now believe is happening. So that's change in climate. What about northern populations? Well, I'm not a anthropologist or a political scientist. I can't really tell you much. But one of the things that I find interesting, and that actually has relevance for Fairbanks, is the fact that if you look at the traditional whaling in Barrow, which is traditionally done with skin boats launched off the ice, paddled towards the whales, which are harpooned and then brought back in, the ice edge up there has been getting less and less stable. Very dangerous conditions at times. if you talk to the local people up there, they have recognized that for quite some time, and as a result, they have, over the past 2 decades or so, really almost completely changed the way they go out and hunt whales. Whereas in the early 80s, and this is for a number of reasons, but in part because it was much more easy, most or almost all of the whaling was done in the spring off the ice. Now, in typical years, you have more whaling being done in the fall with boats, very powerful boats operating under dangerous conditions in open water because the ice retreats. And so we find that, whereas we as scientists are still debating, well, what's happening here, can we make predictions, that if you were to monitor the horsepower of outboards bought in Barrow as a result of this and serviced here in Fairbanks, that would have told you the whole story that, in fact, change is underway. And that, in particular, the people in Barrow are very, very good at adapting to change and making good use of proven technologies, such as skin boats here, but also of whatever, the new 225 Honda four-stroke line has to offer. And I would argue that that is the way you best respond to these things, other than changing what's ultimately responsible here. I should point out that, of course, there's a range of other areas where changes have occurred in northern societies, but again, that's something that we might be able to pick up in the discussion. So the third point then is, if we look at the Arctic as a whole, I've talked about geopolitics. Well, what is geopolitics? Well, if you examine this from the perspective of, let's say you have a whole bunch of coal that you want to get from the Healy coal mine over to Korea. Well, right now, that's very easy, simple, straightforward navigation, the ice-free North Pacific. The question is, of course, would you potentially have a coal buyer or a buyer of some other commodity over in Europe? Well, if you want to get that stuff out there now, it's a very, very long way. You either have to go through the Suez Canal or Panama Canal. And so there's quite a few people who are looking very closely at the way the ice cover in the Arctic changes to find out whether later in the century, and here are some model predictions. If you look at just this picture here in the middle on the right, shows you the best model prediction for ice extent in the summer by the middle of the century. And you can see that there's large areas of open water, both along the northern American continent as well as along Russia. And so it's entirely reasonable to say, well, maybe we can actually use this as a transportation route. And so there's a lot of this planning going on. But at the same time, of course, as we well know, animals that are associated with the ice here, in particular this perennial ice cover, which some models actually predict now is going to go away possibly in the second half of the century, species like polar bear, walrus, etc., are going to be very strongly impacted by that as well. So the question is, if we look at this, what does this actually mean from the perspective of our different neighbors in the Arctic, say Russia, Canada, Greenland, Denmark? And we find that all of our neighbors, in fact, have started to change and redefine the extent of their territorial boundaries. They can do this as part of the Convention of the Law of the Sea that was ratified by these countries. And if you look at this map here, the map at the top right now shows you the extent of international waters in the Arctic, where you can just cruise through, coming through Bering Strait, go across here, come out the other end between Greenland and Spitsbergen, and most of your travel here would be in free international waters. Well, if all of the countries, including the U.S., were to revise their territorial boundaries as they now can, at least those that have signed on to the treaty, these two slivers here would be all that's left of the international waters in the Arctic Ocean. And what's happening, in fact, now is that a lot of these countries are starting to begin a discussion about, well, what actually constitutes a valid claim, what doesn't. Most of this arguably driven not just by the changes in the legal regime, the law, but really by the fact that everybody recognizes that, well, maybe 20, 30, 40 years down the line, I'd like to actually run a shipping route across the North Pole here. So this clearly is having an impact. But it also has a local impact. What I'm showing you here is a map of the latest lease sales north of Alaska for oil and gas exploration. And what's interesting is that this is the first true offshore lease sale in the Arctic, in the U.S. Arctic. It's interesting also that a lot of these leases are actually outside of the coastal waters, where right now, for instance, if you go to Prudhoe Bay, most of the, or really 2 or 3 of the fields that are somewhat in an offshore location are located very, very close to shore. All of these leases that you see here are way further out. And of course, there's some implicit understanding here that as the climate changes, these types of locations are going to be more accessible. And the question, of course, is whether that's a valid assumption or not. What's interesting is that, you know, if you look at some of the sales, for instance, over here in the eastern Beaufort Sea, these have been bought by Shell. And Shell actually is one of the major players in over on the western side of the Pacific, in the so-called Okhotsk Sea. That's part of the Russian Far East, actually borders on Japan. And I would argue that it really behooves us well, in particular here in Fairbanks, where we're thinking about a gas pipeline and other issues, to watch very closely what's happening over there, because Shell right now is in the process of trying things that they really haven't done in that form before with respect to deep water, gas and oil development in ice-covered oceans. But of course, that gas is going to come to markets in areas that we might potentially be interested in serving as well. So to one extent, clearly a lot of this environmental change, which is linked, of course, between what's happening in the Okhotsk Sea, which is basically the neighbor to the Bering Sea, and up here, that link also extends to all kinds of other economic or political aspects of the problem. Now, the final point I want to make here, and then I'll try to wrap up by just showing you what some specific opportunities are, is that this increasing interdependence between the Arctic and the global environment. And really the best illustration that I could come up with on this was this question that maybe some of you also get. You know, you go to a party in the lower 48, or you meet some people in the lower 48, and they say, well, so where are you from? And you say, oh, I'm from Alaska. Oh, okay, that's interesting. And then they say, well, so what do you do up there? And I say, oh, I study snow and ice. And they go, oh, okay, that's really interesting. Well, up until about 2 years ago, the next question, you know, almost invariably was, oh, so have you ever seen a polar bear or a penguin? You know, if they weren't quite up to speed on where the penguins abide. And about, you know, in 2004, and I'm not making this up now. The question was, so what do you think about global warming? And it was almost, I mean, and this is a wide range of people, you know, I'm not talking about my colleagues, really about just people I would meet, you know, whenever I'm on travel or visiting with people. And it was just very, very interesting to see how suddenly the attention has shifted. And so what I would argue, and that is something that I think could be an aspect of the International Polar Year that we should pay very, very close attention to, is that that within our society now, we have reached a point, either individually or as a whole, where suddenly we're starting to realize that, in fact, yes, we do have the power to substantially transform the climate and the living conditions on this planet. And I don't know whether that's good or bad. I consider this, to some extent, you know, it's already happening now. But I think it's a very, very important point to reflect on, and either individually or as a society say, okay, once we recognize this, what are we going to do about it? And I suspect that if you look at the International Polar Year down the line, that may be a very, very important aspect of it. And of course, as you know, I'm not telling you anything new. What we find is that by producing more and more greenhouse gases, there is a clear impact on the climate. There's discussion about, well, what is the factor of natural variability in this? What is the role the sun plays? And you can try to argue this one way or the other, but I think there's more and more mounting evidence that really this is something that is principally different from what we've seen before. And I'd be very, very glad to be proven wrong on this. But what we do find is, and that I think is very, very is well established, is that whatever the causes of the change that we're seeing now, the change that is happening now is likely to have impacts not just within Alaska, but also in the lower latitudes. There's very interesting modeling studies now that show that with the retreating ice edge by the middle of the century, because of the shift in the Aleutian low and the storm passages in the North Pacific, that the American West, Colorado, California, parts of Oregon, is going to have about a third less with respect to water supply as a result of diminished precipitation. That is when people are going to start taking notice of these problems, and I would argue now is the time for us to make clear that we are in fact connected. And this brings me to sort of the summary of these 4 points that I raised earlier, the question about, well, we have these different changes in the Arctic, changes in the environment, changes in the culture, in the politics, and the economics, and of course they're not isolated, they're all connected. And that, again, is an important aspect of the theme of this International Polar Year, that we're starting to see how these things are connected. Now, let me just briefly, for 5 minutes, and then I think I'm within time here, just point out a few of the things that you might either personally or by knowing somebody else who could be interested in this, get involved in, or summarize what are the opportunities, specific opportunities for Alaska during the International Polar Year. You've seen this picture here at the start. This is actually a new climate research facility that's almost built already up in Barrow, that's going to draw a lot of researchers, not just from within the U.S., but other countries as well. And so I think we'll see a lot of visitors in the state over the next 2 years, and that is a great opportunity for exchange. In particular, in the Pacific realm, we find that Alaska is in a great position to engage in a discussion with our neighbors in South Korea, Japan, Taiwan. A lot of these countries have a very, very big interest in Alaska. You'd be surprised how much they know about Alaska. And I think this is only going to increase. And of course, those are primary trading partners for Alaska, and they're also of interest from a number of other perspectives. So Alaska as a natural laboratory, as a key component of an Arctic observing network that's starting to grow. The other big asset that we have is that we have experts who can look back to centuries or even more of knowledge of the environment that is really very much in parallel, something that we need to have more of an exchange with the native Alaskans and their perspectives on the environment and changes in the environment. Again, that's something that I think actually we here in Alaska have made very, very good progress with. And then, of course, there's knowledge transfer, which is also quite well established between different sectors of industry. But ultimately, the big thing is, well, Alaskans are resilient and they are ingenuous. And I think that really is going to help us in playing a major role in the International Polar Year. So I've mentioned this. One of the things that's going to happen, and that I think people who are interested in following this both actively by monitoring some of these measurements that are being made here, is that over the next few years, there's going to be a very significant observing network put into place, not just to help us observe the change, but also to provide data that's of more relevance to people who are actually interested in this. What do I mean by that? Well, you know, these days with the web, you can actually sit here in Fairbanks and follow the evolution of ice conditions in Barrow, in particular events where using a combination of a webcam where you can actually monitor ice on the beach and radars where you can sit here in your office and watch from a radar mounted on the shore and follow the movement of the ice, see whether the ice is stable or not. Here's a little animation that was put together by a former graduate student who was working with me. You can see how the ice breaks off here at different points in time. All of this information is now available in near real time. If you have a computer at home, you can look at this. And in fact, I find that a lot of the exchange with people who have knowledge about these issues is actually quite invigorating and interesting. And I think there's going to be more of this type of exchange during the International Polar Year. So these new types of observing systems are going to be observing systems where you can have your favorite ice flow, or your favorite seal in the Arctic, and you can actually access information about where that seal or ice flow is every day out of the year. The other opportunity, of course, is really more specific to what's happening here in Fairbanks. I'll put this page up again at the end. There's a whole bunch of committees, and yes, you can't get this really moving forward without committees at the university, but there's also a lot of other activities that you can either find out by visiting the web pages or calling this number, and again, I'll leave this up again at the end. But just to give you some examples of things that are happening, there's during the month of the formal kickoff of the IPY, there's going to be 3 very interesting, well-recognized authors visiting. One of them I want to highlight here is Deva Sobel, who's written, among other things, a book about longitude as part of a big cartographers meeting, map makers meeting, basically, that's taking place here in Fairbanks. We have a range of great IPY postdoctoral fellows who've come from various top research institutions here to the university. And there's a bunch of other things that are happening. One that I'd like to highlight for the last couple of minutes here is what we call North by 2020, a forum for local and global perspectives on the North. What this is basically is a sequence of events that includes meetings with people here in the community, bringing in experts from the outside to help us address and discuss in a broader context some of these challenges and opportunities that I've outlined here earlier. And we're working with various stakeholders in the state and in other circumarctic countries on a number of themes that relate about energy, health, food, living resources, and so on. And so this North by 2020 initiative, and again, this just shows you that, yes, these committees can also make nice plots of various things. Don't need to look at this. But that shows us that there's things happening. And I really would like to invite all of you in whatever way to get involved with these things. Visit the museum is going to actually have a range of activities related to the IPY. Talk to people at the university. I think we've come to recognize, or at least I have during those years that I've been here, that the university could play a more important role in the state and also within the community as something of an honest broker of information. But if we want to do that, we have to communicate more effectively. I guess, if I were to talk to you about rangifer's, that wouldn't really get very far, so I got to talk more about caribou, even though I don't really know much about him. But the bottom line is that in all of this, we need your help to keep us on our toes and really get moving forward. And so the question is, what do we see the IPY for as, what's the theme of the IPY for? Well, that's up to us to decide. And I thank you for your attention and welcome any questions.
So, are there some questions out there?
Hi. You talked about weather modification, and I know that there's a HARP research that's affiliated with the universities. Am I correct?
Yes, that's outside of my. I guess I should be specific. There's different types of weather modification. I don't think HARP qualifies, to be quite honest. I think the weather modification that we need to be concerned about is the modification by producing greenhouse gases. I think that's one of the most effective ways of changing the weather. I don't know much about, I guess HARP is about the ionosphere, and while the ionosphere plays some role in weather, really most of what happens is driven by things like clouds, water vapor, carbon dioxide, and things like that.
So if a person wanted to find out more information about that, would you go through the geophysical?
Yes, yeah, exactly. If you're interested in HARP, then definitely visit the Geophysical Institute website. They may even have already some information on that website. And if not, actually Amy can probably point you in the right direction.
Okay.
If you can speak without a mic, you can just shout too. I'll take any type of question. if you don't have questions, I got more overheads too, so you might want to pick your choice there wisely. Yes?
About 30 years ago, people were talking about a coming ice age or global cooling. And then about 10 years later, we got on the global warming. Can you explain that a little bit? What was leading us to that anticipated global cooling?
Well, I guess about 30 years ago, I was busy working on my crayon skills, so I'm not. But I think you have hit on a very, very important point. And if you allow me, I want to take 2 minutes or maybe even 3 to try to explain this as best as I can. Earth is a remarkable planet. We are in a position in the solar system where we're close enough to feel the heat of the sun, but we're far enough away to have major masses of ice present on Earth year-round in some locations. If you go further out in the solar system, next planet over is Mars. A balmy summer day on Mars is the coldest day of Alaska in the winter. If you go closer towards the sun, you get to Venus, where you don't, I mean, if I put my oven on clean heat, it goes up to 490 or 520 Fahrenheit. You don't even get close to a warm summer day on Venus. So the problem is, or the interesting thing is that Earth is sitting in a location where it doesn't take much to nudge us into a complete ice age. And in the long past, very, very long past, hundreds of millions of years ago, there have been periods where I think we're pretty sure much of Earth, including the oceans, were frozen over. Doesn't take much to nudge us into that type of cold or ice house Earth, if you will. But it also doesn't take much to move us over into the other direction where we have no ice. And this year, or this past year, 2006, was a very, very interesting study came out where people who looked at the history of the Arctic Ocean showed that about 40, 50 million years ago, even though the North Pole was roughly where it is now, so you had about half a year of darkness, the North Pole was ice-free year-round, and the summer temperatures at that location were high enough to allow a certain type of water plant that now occurs in places like Thailand and China to grow. So the problem is that it doesn't take much in the way of fiddling with the climate system to either move us into one cold extreme or a warm extreme. In the 1970s, people started to recognize this, and a lot of findings, both from the IGY and other research, suddenly came out, and people started to recognize that, wait a minute, it doesn't take much to really push us into this cold phase. And so that was picked up by the media, and some scientists back in those days didn't have a good enough understanding of how these different things work together because the models weren't good enough either. What we know now, I think, is that ultimately we're still part of an ice age. We're in the warm part of an ice age. If things don't change in a major fashion, it is not at all unlikely to assume that 10,000, 20,000 years from now, it's going to get much colder again. In the near term, it's clear that if we continue putting out greenhouse gases, it's going to get warmer. That really is, I mean, at least personally, I don't think I've seen any convincing evidence, and this goes for the scientific community as a whole, I think, that shows how we would prevent this warming if we don't change the way we're doing business now. But the problem is, and this gets back to where I started, that Earth is so interesting. The climate system is about the last thing that you can visualize as just, turning a knob and something changes. If you turn a knob, you basically change 15 things, and then they change another 100 things, and so it's very difficult to predict. And there is clearly areas that may actually get significantly cooler if we have an overall warming. So I apologize for this very long answer. I'm not sure whether you're satisfied, but my explanation would be in brief that we're only, even now, only learning more and more about the complexities of the climate system. And that may explain in part why, during the 1970s, when they found out that, whoa, there were very cold periods in Earth's history, that they said, whoop, maybe we're headed that way again as well. So the bottom line is, okay, I want to finish, that's sort of, I'll take other questions, but ultimately what this is about, and I think that is important to focus on, is about predictability and uncertainty. How certain can you be that if you plant crops in, Kansas or wherever today, that you can do the same thing 10 years from now? How certain can you be, just to give you another interesting example, how certain can you be if you send a whole bunch of vessels into the, area of the Alaskan waters that are seeing these really, really big retreats in sea ice now in summer? How certain can you be that if you send up a fleet of vessels doing seismic exploration for oil and gas exploration, that those vessels actually will find open water? And it's interesting that last summer, where precisely that was happening, there was a lot of ice in that region, not because the ice suddenly is fighting back in the Arctic, but simply because in some areas you have conditions different from other areas. And so there's always this uncertainty at a local level in making a good prediction. Okay. Any other questions? Yes. Yeah, that's a really good point. Of course, the assumption is that, well, we never want it to end, right? Good times never want it to end. But I think the overall plan is that what we would like to do during the International Polar Year is do a bunch of measurements at an intensity, if you will, that we normally couldn't. So we want to have more instruments out there. There's going to be a lot of satellites in orbit. There's going to be a lot of field cams, a lot of expeditions by airplane, on the ground, with vessels. And by having everybody do that, we can collect a data set that's dense enough to allow us to improve the modeling. Because right now we are at the point where the modeling is probably going to pick up a lot of the slack, if you will. The modelers are really working very hard at reducing the uncertainty, but in order for them to do that well, they need these concerted observations. But the other thing, too, is, and that's something that I'm personally involved in that I think is challenging, but again, something where Alaska can contribute, is that we're now starting to see this transition from research where, somebody like myself, I like being in the Arctic, right? I like going up to Barrow. I would have probably moved there. My wife wanted to move to Seattle, so we compromised. We ended up in Fairbanks. But it's a short commute. So from that perspective, this place is great. But at the same time, you can now put out instruments in that place that allow me to sit in the office. I have a postdoc working with me, Daniel Pringle, who's back there. He put out this sophisticated set of sensors that allows us to sit in the office and literally on a minute-by-minute follow what the ice cover is doing. And only at times where it's really worth for us to go up there do we go up. We can cut down the number of visits to these places, but if we deploy more of these types of instruments, we can also get a much better picture of the Arctic without actually being up there. And I think that's part of the big push of the International Polar Year now, is to really work on improving the types of sensors and the types of autonomous systems, whether they fly by themselves or dive by themselves, so that the hope is that eventually at the end of the polar year, or maybe 5 years further down the line, a lot of this can be done remotely. And for that to work, though, we have to make sure that the data that we produce aren't just useful for the scientists, but they also have to be useful for somebody, let's say somebody is interested in finding out when it would be good to send a fishing vessel out to fish for ground fish in the Bering Sea. Depends very much, if you go for certain types of species, on the bottom water temperature history. And if they have remote information that they can just access from their computer, it saves them time. If they, in addition, have information about the ice conditions, potentially makes the whole trip much more safe. And so making sure that the types of data we produce aren't just, Googled by whoever's bored on their Sunday afternoon, but by people who really have a need for this, that's going to be an important part of the IPY. Yes?
Just a quick question. I think on the slide after this, you had a little something about the state of Alaska. Is there, besides gathering peripheral information and fallout information, that the state is specifically funding and doing in order to gain information that is specific to the state of Alaska and to us up here?
I can't speak for that. There's some people in the audience here with Alaska Department of Fish and Game. I've talked to the Division of Geological and Geophysical Surveys, and I know that maybe not necessarily as part of the IPY, but as part of the overall initiative to have better knowledge of the in particular the geophysical sort of the geophysical baseline information that's important for mineral exploration, or a lot of the stuff related to living resources, that there's a lot of things happening. What I'm excited by personally is that we're now in a position where we can have a better exchange with a lot of people, with different state agencies, or things like the Geophysical Geological Survey of the state. And I actually see this, maybe there's not enough of it now, but I see the next 2-3 years as a great opportunity to have more of a partnership. And that's something that I really value, because for me, and for a lot of scientists, we often have a very short attention span. And so it really helps us with our research to get this big picture perspective that somebody working with a state, here can have. Plus, their knowledge of a lot of these issues that are important on the local basis is way better than, say, mine would be anyway. So I think there's interesting room there for development of a closer and more effective partnership. Well, I don't want to keep you too long. If there's nobody else going once, going twice, all right. Have a good evening.